In previous part of this tutorial, we created geometry for aluminum billet, copper inductor, and surrounding air. And in this part of tutorial, we are going to create a computational mesh and export it to CENOS. So first, we have to change geometry model in Salome to mesh module. Next, we will click on partition that we created before in geometry model and go to create mesh button. We click on it. So now we have to specify algorithm for 2D. We will choose NetGen 1D 2D, which will create automatically unstructured mesh. Here in hypothesis we will select parameters and we will specify the maximum size for any element within this mesh to be 20 mm. For minimum size we can safely use 0. Click OK, apply and close. So now I right-click on Mesh and click on Compute. So you see that mesh for both billet and copper inductor is not fine enough, especially on surfaces. So next step is going to be creation of submeshes. Make sure that mesh is chosen and then click on Create a Submesh button. So now you will see that here geometry field is empty. Thereby, we open this drop-down for partition and select inductor geometry. Now, for 2D algorithm, we will use quadrangle mapping, which will create a structured mesh for us. But first, it will need also some 1D algorithm, which we will choose to be wire discretization. For hypothesis, I select maximum size. And maximum size for any element in our copper mesh is going to be 2 mm. So I click OK. So final step is to define 0D algorithm, which will be for corners and also for surfaces. So we select hypothesis, there is only one, and for element size at corners, I want them to be 1/4 mm. So I click OK. Let's apply and close, and recompute our submesh for copper inductor. So you see that now mesh for copper inductor looks good, it is structured, it has coarse mesh in the middle and finer mesh on the surface. Of course, we could apply the same meshing strategy for our aluminum billet, but we want only fine mesh here on this surface closer to our inductor and not every surface to be fine. Thereby we will create a mesh for billet differently. First we will select again mesh from this window and click on Create Submesh. Geometry field is empty, thereby we will select billet. For 2D algorithm I will use quadrangle mapping, the same as before for copper inductor. For 1D we will choose wire discretization, and for hypothesis I will use the same max length hypothesis. I will set maximum length to be 2 mm, click OK, apply and close. So now we will recompute submesh for billet, and you see that mesh for billet axis looks good. From physical viewpoint it has good refinement enough, but refinement here on the surface is not enough. We need much finer mesh because of high frequencies that used in inductive heating. We need to resolve skin depth. Thereby, we again will create a submesh, but in this case we will create additional submesh not for billet, but only on upper and lower edges of billet. Now make sure that mesh here is selected and go to Create a Submesh tool. For geometry, now instead of inductor, we will select billet out. So if you don't remember what was billet out, the group name of billet out, you can here click on this I bottom, and you will see that those edges I highlighted. So it is here on the bottom and this one on the top. So for those two edges, we will use wire discretization algorithm, and for hypothesis I will choose number of segments. So let's set the number of segments to be 50, and if I would keep this type of distribution as it is now, then those 50 elements, they would be distributed equally, but we don't want them to be equally distributed, therefore I will choose another distribution with table density. When I click on this distribution, then table opens. Here you see that there is parameter t, which is from 0 to 1, and function, which is also scaled from 0 to 1. T means dimension, and f means fineness of mesh. So higher values for f means finer mesh. So I will add additional row here, and we want to mesh here on axis to be coarse and on the surface to be fine. Therefore I will add additional point at 0.9, which is again normed to 1. Fineness on the axis we want to be 10 times smaller than that fineness which will be on the surface. And here we will create just additional point. So you can see this visualization how elements will be distributed on our edges. So here we have linear growth of elements in 2 times, and starting from here up to the end we have 5 times finer elements here on the surface than here. So I click OK, apply and close, and now Salome asks us, because there were 2 conflicting submeshes defined on billet, we need to select priority, which submesh we want to create first and which second. So I click on Yes button, and I want the last mesh to be created first, so it needs higher priority. So I will click on this button here and make it the first priority. Firstly, Salome will create mesh for edges, and then it will create a mesh for billet domain itself. So I click apply and close. Now I will recompute submesh for edges and recompute submesh for billet itself. So if you look on the top of this billet, we see that mesh looks good. So here we have coarse mesh and here we have very fine mesh. That's good. But if we look here on the bottom of billet, we see that direction was opposite. So we have to fix this. Again, we go to the last submesh that we created and right click and select Edit Submesh. Next, we have to modify our hypothesis. So I click here on this button, and let's move those windows to windows. Let's remove this line here. So you can see that there is a window called Traversed Edges. Also, you can see in our Salome window that our billet here on the bottom and here on the top, there are 2 arrows, and those arrows have opposite direction. And what we need to do is to click on this lower arrow here on the bottom. We have to click it, select it, add it. So now, because the lower and upper edges were in one group, Salome added them both. We have to make sure that we selected the right one. So I will just make sure that it's number 4. So you can see now it's white here. So number 4 edge is the right one. So we have to remove this number 9, which corresponds to the upper edge. And now we click OK. Apply and close. We will recompute the submesh for these edges. We now recompute the submesh for billet. And you see that we fixed that problem. Now our mesh for billet is structured and it has very good refinement here on the surface. So now we can recompute the whole mesh for our computational domain. So you see that it looks good for both our electromagnetic problem and for thermal problem as well. And there is one very important final step. We have to add geometry groups, those geometry groups, to our mesh. So I select my mesh and go to Mesh button and then click on Create Groups from Geometry. Now I hold my mouse and select both body groups and boundary groups and make sure that they are here, the same that we selected, and I click Apply and Close. So Salome now added those geometry groups to mesh, and finally what we need to do is to export this mesh to CENOS. We click on Tools, Plugins and Mesh to CENOS. When this window shows, then it means that our mesh was successfully exported to CENOS. So I click OK. Now we will switch back to CENOS, and this is the end of our tutorial part for meshing, and in the next part of our tutorial we will talk about how to set up our electromagnetic and heat problem and solve it. So for now, thank you.